Okay, so what we're looking at today are cash flows. Cash flows are not any different than our future value equations, except we're going to do them over a longer amount of time. We're going to start at time period 0, and we're going to do a series of cash flows over the entire time, 3, 4, and 5, and we're going to calculate these independently. So first we would have something like we did in the first equation where we have $100 in time period 0, but then maybe in time period 2, in time period 1, we decide to put in $200. And then in time period 3, we decide to do $300. And in time period 4, we decide to do 400, and in time period 5, purple, we decide to go back to 3 and nothing at the end. Okay, well, each one of these is going to have a separate time limit. For example, the 100 is going to get future valued over the entire 5 years. But the 200 is only going to get future valued over a 4-year period. 1, 2, 3, 4. And so it needs to be calculated separately. Let's do these one at a time and see what happens here. So for the 100, we're going to say, remember our future value equation, future value is equal to PV 1 plus R to the N. So our present value here is 100, 1 plus R. I haven't given you an R. Let's assume that it's going to be 7%. So 0.07 over how many periods? 1, 2, 3, 4, 5 periods. So that goes over to the 5, and then we speak that one forward. And so that looks like, let's see, 1.07, 5 periods times $100. It gives us a total of 140.25. That might be outside your screen, but there it is, which is nice. And it's nice to calculate, and we have it, but we can't do all of these others because they're not only different numbers, there's also different periods. So let's go take a look at 200. We're going to calculate 200. We're going to run right past that one, and we're going to do the same equation, but we're going to do this one independently. It's going to be 200, 1 plus 0.07, but it's not to the 5, right? It's going to be, if this is the first period, the 0 period, then it'll be 1, 2, 3, a total of 4 years that we're calculating here. And that's going to run out, and it's going to become 1.07 xy 4 times the $200 in this example is going to turn into $262.15. Same thing for the 300, and we continue. 300, and we're going to calculate it out. So this becomes 300, 1 plus 0.07, and now it's going to be 3 years because we only have, 1, 2, 3 years left. And that, if we type it into our calculators, is 1.07 3 times the 300 is equal to 365 and 51 cents. We can continue this process. Let me do one more, just so that we're all on the same page. We do one more. So here's the 400. That's going to be 400, 1 plus 0.07 squared, because there's only 2 years, right? 2 years left. Whoops. Squared, and that's going to give us 1.07 squared times our 400 is going to be 457.96. We would do the same thing for 300 here, but let's just scratch this out for now. Let's just pretend that that's a 0, and that'll be 0 when we calculate that out. So now we have 1, 2, 3, 4 different payments that we can calculate, that we have calculated. 1, 2, 3, 4. And now we look to see what our value is in time period 5, because that's what I'm interested in. I'm interested to see what my future value is going to be after 5 years of this uneven cash stream. So let's go back and take a look at it. Well, I've got a 0 here and a 0 here. If I turn this one around and I bring it down and bring it over, it's going to be 0 here. But then I can add them up. And if I add them up, now that they're all in the same time period, this equation is going to run to 140.25 plus 262.15, and that's going to give me 140 plus 262 is going to give me 402, right? So if I add these two together, let's make some space the other way here. If I add these two together, it's going to give me 402, and if I add that to the 365 plus 365, it's going to give me 767. And if I add that to the 457 here, plus this one, plus 457, that's going to give me 1224. And since all my other guys are 0, my total number down here is 1224 and change. Okay, and this becomes the future value. Let's make that an equal sign just to make it clear. And that becomes the future value of my original question, which was, how do I calculate the future value of all of these different cash flows? The answer is, I do them one at a time. 1, 2, 3, 4, 5. And when I add them all up together, I get 1224. In a separate lesson, I'm going to show you how to do this. I'm going to show you how to do this in using a calculator, but for now, let's talk about what this equation looks like. The future value looks nothing more than adding up each one of these, this guy plus this guy plus this guy. And so our future value equation looks very much like those series. So it's going to be present value, say, sub 0, 1 plus I, in this case to the 5th, but it would be, in this case to the 5th, but we would do it, say, n. Now let's just keep it simple for now. You do it to the 5th plus the second present value, which is time period sub 1, times 1 plus I to the 4th plus, and the next one, present value time period 2, 1 plus I to the 3rd plus, and so on, until we get to the final one, which is, in our case, is PV5, present value in series of 5, 1 plus I to the 0. But 0, I'm writing down 0 here to show you that we go all the way to the end of the period, but every time you have anything by 0, this is just going to turn into the number 1, and it converts down. It makes it real simple. At the very end of the day, we have a summation equation, see if I can do this right, that looks something like present value of time t times 1 plus I, whatever the interest rate is, over n minus t. And this whole equation, let me switch colors here. This whole equation is a very fancy, algebraic, formulaic way of saying calculate each one, 2, 3, 4, 5, 6, calculate each one of these one at a time, and then add them up to get a final answer.